Okay, in this example then we've got two forces acting at point O. The resultant has magnitude R and acts perpendicular to the 6 Newton force as shown in the diagram. And we need to calculate the angle between the resultant force and the 13 Newton force, and also find the value of the resultant force. First, let's examine how this is different to the problems we've seen previously. So this force R here is not an actual force acting on the particle. It's the consequence of the 6 and the 13 Newton forces acting on the particle. So it's like saying, if we replaced the 6 Newton and the 13 Newton force by a single force, it will be to the right and have magnitude R. To start with, I'm going to label this angle in here theta. This is the angle between the 13 Newton force and the resultant force. That's what I want to find. To do that, I'm going to resolve vertically. I'll take upwards to be positive. So I have the 6 Newton force acting upwards. I have a component of the 13 Newton force acting downwards. That will be 13 sine theta. And as the resultant force acts to the right, then vertically we should have no net force. Rearranging, we get 6 equals 13 sine theta. And then dividing through gives us sine theta equals 6 over 13. And if we put that into our calculator, we get 27.5 degrees to 3 significant figures. Next we'll find R. To do that, notice that it acts completely to the right, and the only force on our original diagram acting to the right is the 13 Newton force. So we can say that R equals 13 cos theta, where theta is 27.5 degrees. And if we put that into our calculator, we get 11.5 newtons to 3 significant figures. Okay, here's a similar problem for you to have a go at then. Pause the video, then come back and check your solution against mine. Right, so this is similar to the example then, but this time rather than having a missing angle, we've got a missing force. The resultant force acts vertically. That means if we resolve horizontally, we should have a net force of 0. To the right, we have F cos 40. And to the left, we have 34 newtons. As we said, no net force in the horizontal direction, that must equal 0. Rearranging, we'll add 34, divide by cos 30, we get F equals 34 over cos 40. And if we put that into our calculator, we get 44.4 newtons to 3 significant figures. Next, we'll resolve vertically. The only force we have acting upwards is F. We'll have F sine 40, and we know the consequence of that force is the resultant force. So we get R equals F sine 40, so 44.4 sine 40, which equals 28.5 newtons to 3 significant figures.